Hey everybody, lesson 6.5 today, and one of the core concepts is going to be how to write an indirect proof. And I know that's a vocab term, but all that means is a proof by contradiction. There are some steps written here, and the first thing is you're going to identify the statement you want to prove, but what we do is we start by actually writing assume, and then we're just going to assume that that statement is false by assuming the opposite being true. Okay, we'll see that later. And then step two is we are going to reason logically until we reach a contradiction. And then step three is we're going to point out that the desired conclusion must be true because the contradiction proves that our temporary assumption is false. But before we get into that, I'm just going to go in order with the student journal, as always, is we can look then down to one of our first theorems. This is the triangle longer side theorem. And this just says basically, I'll just read it. If one side of a triangle is longer than the other side, then the angle opposite the longer side is larger the angle the opposite the shorter side. So if we look here, AB is longer than BC because 8's bigger than 5. Now, what angle helps create this segment AB? That's angle C. So if AB is longer, that means angle angle C is going to be larger. And if BC is smaller, angle A is going to be smaller. So the smaller angle pairs with the smaller side, the larger angle pairs with the larger side. So this is starting with angles and starting with segments, 9 segments, and then ending with angles. Where the next theorem is the opposite of that. This basically says if you have two angles and one's larger than the other, the larger angle will be paired with a larger or longer line segment or side of a triangle. So since 50 is larger than 30, the side opposite, which is BC, is going to be larger than the side opposite 30, which is AB. Okay. So those are the two theorems that we have so far. And then we get into a pretty major one here is the triangle inequality theorem. This says the sum of the lengths of any two sides of a triangle is going to be greater than the length of the third side. So if I gave you a list of possible side lengths of a triangle, this would allow us to determine if we actually can make a triangle. Now, if we were physically in class, I would probably take some pencils and show you that if they're the same and by breaking them, and I'd have a visual of why this works. But for the sake of simplicity here, basically this is an easy check. I'm gonna write down this is an easy check. If you wanna actually do this, and let's say you have all the sides. Now again, this only works if you have numbers. Later, when we have expressions, a little different. This basically means you can take the two smallest sides. If you add together, they have to be greater than the largest side. Now, notice there's no equal to symbol. They have to be greater than the largest. All right, so let's actually get into practicing some of this stuff. Here we go. All right. Extra practice. Here we go. Write the first step. Now, this says first step in an indirect proof of the statement. So remember, with an indirect proof, we want to assume the opposite. So let's see if I can write small enough for this. Number one says not all students in a given class can be above average. So if we want to do an indirect proof, that means we want to do a proof by contradiction. How we would start the proof is we would start by assume, you have to start with that word, assume, and then what's the opposite of not all students? That would just be all students. So assume all students in a given class can be above average. Now, how does that help in a proof? Well, think about this. If you want an average, you take all the scores, you add them all up and divide by how many you have, and that means Some students literally have to be below that average because remember, average is like in the middle. You can't have everybody, every single buddy, 100% of everybody be above the average. It just doesn't work. Okay, so that's how you would sort of go about tackling a proof like this. All right, number two, no number equals another number divided by zero. So again, we're going to assume the opposite of the statement. So we're going to assume, okay, we're going to assume a number equals another number divided by zero. And then eventually, if we mathematically show dividing by zero, we should know that that's a big no-no in math. All right, the last one. It says the square root of 2 is not equal to the quotient of any two integers. So we want to assume the opposite. So we're going to assume the square root of 2 is equal to the quotient of any two integers. Now, why does that make sense? We know the square root of 2, well, hopefully we know this, is called an irradical number. Sorry, not irradical, irrational. I almost said irradical. Irrational. Sorry, irrational. Rational numbers are numbers that can be written as a ratio between two numbers. Okay. So basically, irrational numbers are numbers that are decimals that go on and on forever and never repeat. And any other number that we can have doesn't fall in that category is basically a rational number, where rational numbers you can write as some type of ratio or a fraction. Okay. Just so happens the square root of 2 we cannot write as the same thing as one number divided by another. All right, so that is the first part of an indirect proof. Okay, now let's go to the next part. Now let's get away from those writing those first statements and look at determine which two statements could contradict each other. And then it says explain your reasoning. All right, let's look at the first one, 4. It says triangle LMN is equilateral, but then it says B segment LM is not equal to MN. These contradict each other. And the reason why these contradict each other is because in an equilateral triangle, all sides are equal. So an equilateral triangle, all three sides are congruent or have the same measurement, where this says one of those isn't. Okay. And it's true that angle L, that measurement, is going to be the same as the measurement of angle M. That's true for an equilateral triangle. Number 5, triangle ABC is a right triangle, right? It's a right triangle. Now, could angle A be acute? Well, if I have a right triangle here, and this is 90 degrees, it just so happens both these other two angles have to add to me 90, so both of these angles are acute. So that works, but you can't have one of the other two be obtuse because an obtuse angle is greater than 90, plus the 90-degree angle and the right angle makes more than 180 degrees. So those ones that don't work would be A and C, and that's because you can't physically have another angle that's bigger than 90, or your triangle sum theorem does not work out. All right. Let's go into our triangle stuff from earlier. List the angles of the given triangle from smallest to largest. Remember, if you want the angles from smallest to largest, we want to do the sides smallest to largest. So let's look here what we have. I'm going to find my largest side. Obviously, my smallest side, because the smallest to largest. My smallest side is 6, and then opposite 6 is angle C. So smallest is going to be angle C. The next smallest is going to be 8. 8 is formed by angle A. And then the last one would be angle B. So same thing for 7. My smallest number is 7, which is angle D. The next smallest is 15, which is angle E. And then we'll have angle F as our last one. And then number 8, smallest side would be 11, which goes with H, so angle H. Next is 14, which goes with angle J. And we have 16, which goes with angle G. Moving on, man, we are just cruising through this. We have one section left here with in questions 9 through 12, and then question 13 is different. Is it possible to construct a triangle with the given side lengths? If not, explain why. So remember the easy way to check. Take the two smallest sides, which would be these. Add them together. 3 plus 12. Is that greater than 17? This is 15. This is 17. 15 smaller, so this would be a no. And why? Because the theorem, the triangle inequality theorem, says they have to be greater than largest. So it just doesn't, when it says explain why not, it doesn't fulfill the triangle inequality theorem. All right, number 10. Remember, easiest thing is just take the two smallest ones. 5 plus 16, compare that to 21. 21 and 21 are the same. Again, this would be a no. And why? The triangle inequality theorem says that the two smaller sides have to be greater than the third side when you add them together. So that's a no. Number 11, take the two smaller ones. 7 plus 5. How's that compare to 8? I get 12, which is greater than 8, which is yes. So why does this work? Because of the triangle inequality theorem. Get the theme here. So I'm not going to keep doing those explanations. Last one, I'm going to put these small ones together. I'm going to get 13 compared to 11. That's bigger, so yes, this works. Now, the last one, question 13, takes a little bit more work because it says the triangle has two sides with lengths 5 and 13. Describe the possible lengths of the third side, which means we have some options here. We have to think about testing all three of those. So what we have is we have a side that's 5. Sorry, I do that sometimes. We have a side that's 5. We have a side that's 13, and we have a side that's x. We don't know what it is. The problem here is we don't know if x is the small side or not. So if you remember, you take any two sides, add them together, they have to be larger than the third one. So let's start with a basic one. Option number 1 here is I can take my side I don't know, which is x, add that to 5, and we know that has to be greater than 13. So when I solve, x is going to have to be greater than 8. Okay, x has to be greater than 8 no matter what. Okay, remember, because it wasn't just the two smallest sides, but it said any two sides have to add to be greater than a third side. So x has to be greater than 8. Option number 2 is now we can do it the other way. We can say x plus 13 has to be greater than 5. Wait a minute. 13 is already greater than 5. So no matter what, we can't have a negative value for x, right? So I'm not even going to worry about that because this would say x has to be greater than negative 8, and we can't have negative values anyways for side lengths. And so that doesn't quite make sense. So I'm not going to worry about that. And let's do the last one. Option 3, I'm going to write down here, maybe a different color here. Option 3 is that 5 and 13 have to be greater than x. Okay, so if I do this, I'm going to get 18 is greater than x. So I'm going to swap these where the x, notice the 18 is getting eaten. So I'm going to keep the 18 getting eaten here, and I have x is less than 18. So this just so happens to be a compound inequality where we would say that x has to be less than 18, but it also has to be greater than 8. So here's our sides. X has to be between 8 and 18. Just can't ever equal those. All right, those are your notes. If you have any questions, reach out. If not, we'll see you in class or in the next video. Have a good day.